Hello students and welcome back to Diksha Karnataka YouTube channel, and you are watching PU2 Brahmastra series. Today is day 9 and we are going to discuss a very important chapter of physics, that is current electricity. Those who are following our 100 heart challenge, this is also the part of 100 heart challenge this week. So your PU2 preparation will be done from this lecture. So if you are wondering what all we have covered, what all we are going to cover this entire week, so we have the entire week's plan. You can check. So Monday chemistry class is already done, aldehyde, ketone and carboxylic acid. Today we are doing physics, current, electricity. Okay, as usual, Wednesday will be biology, human health and diseases. Okay, Thursday again chemistry, amines will be there, and Friday will be again physics, moving charges and magnetism. Saturday maths and biology, and Sunday maths. So if you are wondering what all are going to happen in this channel throughout the week, you can take a screenshot of this and save it, and you can check whenever you want. So without any delay, let's start with the blueprint of the chapter. So there are 3 blueprints from this chapter. As you know, there are 3 blueprints shared by the PU board, and we will analyze all the blueprints. First blueprint says one MCQ question, that will be HOTS question, right? So one HOTS question. Second blueprint, and there will be a short answer type 2 mark question. There is no fill in the blanks. There is no short answer type 3 marks question from this chapter. Fill in the blanks and short answer type 3 is blank for all 3 blueprint. So it is very clear that there will be an MCQ coming from this chapter. Okay, it either be a HOTS question, which is little harder, then there will be short answer type 2 mark question from this chapter. And very important is that from this chapter, if you see, all 3 blueprint has one long answer type question. Compulsory question will come, understanding or application based question, and all the numerical questions are HOTS question from this chapter. Okay, so all the numerical questions will be slightly difficult, not super difficult. If you see the previous year patterns, a HOTS question means slightly application oriented. There will be some diagram related questions, maybe some understanding, some little deeper understanding based question. Okay, if you understand the concept, then you can solve this. Okay, it will not be simply just put the formula, get the answer type of questions. Okay, so easy. Now let's discuss what all we are going to discuss in our lecture today. So we are going to discuss 15 MCQ questions, no fill in the blanks, because fill in the blanks is not important from this chapter. Then we will discuss 5 2 marks question, that should be sufficient. I will give you some extra additional tips if that may be helpful for you. Other than that, we will discuss 3 5 marks question, very important. Okay, and 5 numerical questions from this chapter. So let's start with the first MCQ, statement 1 and statement 2 type question. So statement 1 says that the resistivity of metals increases with increase in temperature. Obviously the resistivity is directly proportional to the temperature. As the temperature increases, resistivity increases. Otherwise resistivity depends only on 2 things, that is the material and temperature, right? So resistivity is directly proportional, so it increases with the temperature. Increasing the temperature of metals causes more frequent collisions of electrons. This is also true. More frequent collisions of electrons actually increases the resistivity, right? So more electrons are getting heated up, more heated electrons, they collide with each other, and they find it difficult to travel from one end to another. That's why the resistivity increases. Okay, both 1 and 2 are true, and 2 is the correct explanation of 1. So yes, this is the correct answer. It can come as assertion and reason based question as well. So in that case also, this is a correct answer. Okay, so both statements are correct, and second statement 2 is the correct explanation for statement 1. Now let's move on to the next question. Identify the wrong statement from the following. Okay, you have to identify wrong statement. So out of the 4 options, 3 are correct, only 1 is wrong, right? So drift speed acquired by free electrons per unit electric field is called mobility. That is the definition of mobility. So this statement is a correct statement. The conductivity of semiconductors decreases with increase in temperature. Yes, this is part of semiconductor conductor chapter, but yes, the conductivity of semiconductor do increase as you increase the temperature. Okay, the conductivity of conductors decreases with increase in temperature. Yes, the conductivity of conductors also decreases as you increase the temperature. Alloys are widely used in the construction of standard resistors. Okay. Now carbon is mostly used in the construction of standard resistors, not alloys. The correct answer is option B. Why? The conductivity of semiconductors decreases with increase in temperature. No, conductivity increases. Conductivity increases. Okay, alloys sometimes are used in standard resistors, not very common, but it is used. Okay, in standard resistors. So in especially in the resistance box that you use, so alloys are actually used in standard resistors, but conductivity of semiconductors decreases. Okay, that is incorrect. Conductivity of semiconductors increases with temperature. Okay, conductivity of conductors decreases with temperature, but conductivity of semiconductor increases with temperature. So correct option is option B. Question number 3. A wire has a non-uniform cross-sectional area as shown in the figure. A steady current I flows through it. Which one of the following statement is correct? So in this case 4 options are given, only 1 is correct. In the previous question 4 options was given, only 1 was wrong. Here at 3 are wrong, only 1 is correct. So you have to identify which one is correct. Okay, the drift speed of electron is constant. The drift speed, we know that I equals to NEAVD. This is the formula that you have to remember. So drift speed is basically I by NEA. Now N is number density, which is constant for a metal at given temperature. E is charge of an electron, this is also a constant. I is the current, assuming constant current is flowing, right? Steady current is flowing, so I is also constant. Only thing is area. Now you can see that area is less here and area is more here, so definitely drift current is not constant. Drift current proportional to 1 by A. So as the area increases, drift speed decreases, right? The drift speed of electron increases while moving from A to B. So as you can see, drift speed is inversely proportional to the area. So here drift speed will be more, here drift speed will be less. So this is also incorrect. The drift speed of electron decreases while moving from A to B. Yes, this is the correct statement. Okay, so drift speed of electrons decreases as it is moving from A to B, because drift speed is inversely proportional to the area. So as the area increases, drift speed decreases. Okay, the drift speed of the electron varies randomly, which is obviously not correct, right? So correct answer is option C. You have to be careful while finding such questions. You have to understand the reason behind it. It's kind of a hot question, right? Next question is the resistivity of metallic conductor dash with decrease in temperature. So the resistivity of metallic conductor dash with decrease in temperature. So obviously resistivity increases. Okay, so correct answer is option A. Resistivity increases with decrease in temperature. They just tried to confuse you. Okay, this is a understanding based question, slightly understanding based question, but this can considered as a remember based question as well. Okay, next question is Kirchhoff's junction rule is a reflection of. So you have to understand the logic behind this question. What is the Kirchhoff's laws? There are 2 Kirchhoff's laws. One is Kirchhoff's junction rule, another is Kirchhoff's loop rule. Now Kirchhoff's junction rule says that whatever current, total current entering a junction, okay, equals to the total current exiting the junction. Suppose these currents are entering, these currents are exiting. So he says that total current entering is equal to total current exiting. That is basically the conservation of charge, right? So this is basically represents the conservation of charges, not conservation of energy. Conservation of energy is the other law, which is the loop rule. Okay, in the loop rule it says if you go in a closed loop, the potential drop should be 0. Okay, that is basically conservation of energy. Okay, whereas junction rule is conservation of charges. So you should be careful. If they say junction rule, it will be charges. If they say Kirchhoff's loop rule, it will be energy. Okay, now next question. The value of internal resistance of an ideal cell is. So the value of internal resistance of anything ideal generally means that the resistance is 0. So obviously ideal means resistance will be 0, not infinity. Obviously these two values are irrelevant. Only 0 and infinity you need to consider. In this case, for ideal battery, because the resistance is connected in series, okay, for ideal battery it has to be 0. If it was connected in parallel, then in that case it will be infinity. We will see that in case of voltmeter and ammeter in our next chapter. Okay. When current flows through a conductor, its temperature, when current flows through a conductor, its temperature increases. Okay, obviously for any conductor, as current flowing through it, it converts into heat energy, and basically that's why its temperature increases. Next question, the SI unit of current density. It came last year's question, that is 2024 question. Okay, SI unit of current density is ampere per meter square. You have to be careful. Some students answer ampere per meter cube thinking that it is a density, so it should be ampere per meter cube. No, it is ampere per meter square. Current density J is defined by current per unit area. Okay, so this is the current density. Now the magnitude of drift velocity per unit electric field. If you remember a few questions back where we are supposed to choose a correct statement, incorrect statement, there it was given as a correct statement. What is the statement? The magnitude of drift velocity per unit electric field is the mobility. Right? It is the mobility, because mobility is defined by drift velocity divided by electric field. Right, so drift velocity divided by electric field. Now if you make this electric field 1, then drift velocity is directly equals to mobility, right? So drift velocity per unit electric field. This is how you write it. So this is just a way to say, but actually this means this. Okay, next question. Which of the following characteristics of electron determines the current in a conductor? So what are the following characteristics? Only thermal velocity, drift velocity alone, both thermal and drift velocity, none of the above. So both thermal and drift velocity both are responsible. Okay, because of the thermal increase in temperature, electrons will move. Okay, that is a random motion, but there will be some associated current provided with it. Okay, and if there is an electric field, there will be a drift velocity as well. Okay, so based on that, thermal velocity and drift velocity both are responsible for flow of current in a conductor. Next question, question number 11. A piece of metal is to be converted into a rod of highest resistance. Okay, which of the following is the best choice for the length and the diameter D? Okay, so you should remember that the resistance is basically given by rho L by A. Now A is area. Area is basically pi r square, or pi d by 2 whole square, right? Radius is half of the diameter. Excuse me. So now, if you see that basically resistance is directly proportional to the resistance and inversely proportional to the square of the diameter. So higher the diameter, and higher the diameter means resistance will be less, higher the length, resistance will be more. So from this we can choose the correct combination is option D, where highest length and lowest diameter. Okay, you have to remember whatever is directly proportional, that should be chosen as more, whatever is inversely proportional, that should be chosen as less, so that you can get the maximum resistance. If they ask you minimum resistance, then this should be the answer. This is the answer for minimum resistance. Okay, so in case they ask you the same question and they say, okay, what will be the minimum resistance, then length will be minimum, diameter will be maximum, so that should be your answer. Now, a steady current I is flowing through a conductor of uniform cross section. Conservation of momentum, conservation of current density vector. I think this question is incorrect. You can cross this. The question statement is not given. Okay. Next question 13. A wire of length I is wire of length L. Okay. Wire of length L is stretched double its length. Okay, the resistance of the wire gets doubled, the resistance of the wire gets quadrupled, the resistivity of the wire gets doubled, the resistivity of the wire gets quadrupled. Obviously, as you know that resistivity is independent of the length, so resistivity will not change, so option C and D is gone. So you have applied the lifeline of 50-50 if you are playing KBC, right? So in KBC there is a thing called 50-50. I want to take the option 50-50. 50-50 option is already provided to you. Okay, so only thing that you need to consider is resistance of the wire gets doubled or resistance of the wire gets quadrupled. Okay, the length of the wire is stretched double. So we know that. Now here you have to understand R is equal to rho L by A. Now even if you have double the length, okay, its area will also change. Okay, if you increase the length, the area becomes half, right? Why? Because volume remains unchanged. So volume is length times area. Okay, now after you increase the length to 2L, okay, volume should remain constant. Now suppose the new area is A dash. So you can calculate the A dash to be A by 2. Right, if you compare these two, L cancels, so A dash equals to A by 2, or if you put the new resistance value, new resistance will be rho times 2L divided by A by 2, or 4 rho L by A, or 4R. So resistance becomes quadrupled, okay, or 4 times. Quadruple means 4 times. Okay, doubled. Obviously you should read between the lines. Even if you are not doing the calculation, how can you answer this question? First of all, you should remember that if length becomes double, resistance become quadrupled. If length become thrice, the resistance become 9 times. Basically it is the square of the change, right? If you are following my KCET series, there I have discussed this, right? So resistance, new resistance is square of the fraction with which it is changed, right? If its length is halved, then resistance will be 1/4, right? So that's how it's changed. Now, but you can guess the answer. How? Obviously resistivity is not changing, resistivity is constant, so you can remove this C and D. Now if the length is doubled, it is very it looks like the resistance will be doubled. Definitely they will not ask you if the question is so straightforward, so you can guess quadruple should be the probable answer, right? This is how you can guess an answer. You should eliminate all the options. What are all the options that you should eliminate? Next question is, Ohm's law is applicable to diode, transistor, electrolyte, conductor. Obviously it is not applicable to diode, transistor or electrolyte. Okay, they are not ohmic conductors. It is applicable to only conductor. Okay, conductors are ohmic conductors, normal conductor, metallic conductor. Masses of 3 wires of copper are in the ratio of 1:3:5 and their lengths are in the ratio 5:3:1. The ratio of their electrical resistances are. Okay, now here this is slightly complicated question. First of all, you have to understand that this will not be 5:3:1 because that is the most obvious answer. You have to remember that mass is related to volume. Okay, because density is constant. Okay, because they are all having same density. Okay, mass is related to volume, right? If they give you the same question, okay, saying that wires of same cross section, if they give you the answer same cross section of length 5:3:1, then you could have simply said, okay, the diameter is same, so the resistance will be directly proportional to their lengths, right? In this case it is not. You have to solve this question. How to solve? Slightly longer question. It is actually I have taken this question from your one of the old KCET paper, so maybe slightly difficult question, but not super difficult. You can consider this as a HOTS question. So HOTS question, many of the HOTS question come in previous years are actually taken from old KCET papers. So I thought maybe this question is relatively important, so that's why I have taken it. How to solve it? So mass is directly related to volume. Okay, so because we know that density is mass by volume. So mass is basically density times volume. Okay, now what is volume? Volume is length into area. Okay, now suppose the mass of the first wire is, we will do it by one wire, first wire. Okay, mass is x for the first wire. Okay, then for second wire the mass will be what? For second wire mass will be 3x, and this is mass. So for third wire mass will be 5x. Okay, now what is the length? Suppose the length for the first wire is 5k, then second wire will be 3k, and fourth wire will be 1k. So what is our target? Our target is to find the area. If we can find the area relationship, then eventually x, k, they will all cancel. Okay, for simplicity you can simply just consider these values without x or k, that is also fine. Okay, if you don't want to waste too much time, you can simply take 135 and 531. Okay, now what is the relationship between mass and volume? Mass is directly proportional to volume, so you can take the density to be 1, so mass is directly equals to volume. These are all approximation method, so definitely you will not get, if you want to solve some other question using this method, it might not work, but for this problem this is work, because they are directly proportional, so you can take any proportionality constant to be 1. Okay, now so for the first wire mass is 1. Okay, so mass is volume is equal to length into area, right? So volume equals to length into area, we have seen just previous problem. So mass is 1 for first wire and its length is 5. We want to find the area, so area is 1 by 5. Okay, so what is the area? Area is 1 by 5. Now what is the area for this? Area for this will be 3 by 3, that is 1. And what will be the area for this? This will be 5 by 1, that is equals to 5. Okay, clear? Why it is so? Because it is mass divided by length. As you can see, okay, area is basically mass divided by length. Okay, so area is mass divided by length. So if you have calculated for one, you can calculate it for the all other three. So it becomes 1 for this, 5 for this. Now you have to calculate the resistances. Resistance is rho L by A. Okay, so resistance 1 equals to rho L is 5, A is 1 by 5. So it is with 25 rho. R2 will be rho L is 3, A is 1. So it will be 3 rho. And R3 will be equals to rho L is 5, area is also 5. Sorry, L is 1, my mistake. L is 1, area is 5, so it will be 1 by 5 rho. Okay, so what is the ratio? R1 is to R2 is to R3 equals to 25. Rho will be cancelled, so we will only write the values. (25) is to R2 is 3 rho, so 3 is to 1 by 5. Now this is not done. What you have to do, you have to remove this 1 by 5 by multiplying all the terms with 5. So 5 25s are 125 is to 15 is to 1. So 125 is to 15 is to 1 is the answer. Okay, also here you might guess this or this is reversed, but you see this is also reversed. right? So basically this will be the answer, 125:15:1. Okay, and maybe in exam they will give you some easier form of this question, but this is a very interesting question to ponder, think about. Okay, so how to solve this question, because this is a little bit hot question, so you have to practice such questions to train your mind. Okay, now let's move into the 2 mark section. So first question is, define drift velocity and mobility of free electrons in conductors, or define mobility, mention its SI unit. So as I said, I will give you options. So define drift velocity and mobility. So either they will ask you both definitions, or they will ask you mobility, definition of mobility and its unit. Okay, both are very common questions. It is there in your previous year questions as well as in your sample papers. Okay, so drift velocity is the average velocity with which the free electrons drift under the influence of an electric field. This is very, very important. Okay, the drift velocity is the average velocity. So average velocity, okay, with which the free electrons drift means they move. Okay, so what is the meaning of drift? So suppose you have a water body, okay, say a river. Okay, so if you put your paper boat on the river, what happens to that paper boat? The paper boat sails along with the waves, right? So wherever the river is moving, your boat will also move. Okay, when we were kids, we used to sail paper boats on the rainwater. Okay, so rainwater used to flow and we used to sail our paper boats on the rainwater, so it travels a long distance. So that was a fun for us. So similarly, drift means electrons are riding the electric field and they are moving. Okay, so electrons are moving in the opposite direction of the electric field, so that's why it is called drift. Drift means they are as if they are floating, they are moving as in a floating state. That's why it is called drift. Okay, so electrons drift. So this term, I feel that many students don't know the meaning of drift, so I explained this term. Okay, so this is like a floating on a river. Okay, wherever they are taking, you are going in that direction, right? In case of electric field itself does not move, but the electrons are like the because of the electric field, presence of the electric field, electrons move. That's why it is called drift velocity. Okay, so drift under the influence of an electric field is called drift velocity. And what is mobility? Mobility is the of the free electron is the defined as the drift velocity per unit electric field, or drift velocity of electron per electric field applied. Okay, per unit electric field. Directly you can write drift velocity per unit electric field or drift velocity of electron per unit electric field. Both are okay. The SI unit of mobility is very important: meter square second inverse volt inverse. Okay, so this is the mobility unit, or you can write it as meter second inverse Newton inverse Coulomb. But I feel this is the most easy way to remember. Meter square second inverse volt inverse. Meter square second inverse volt inverse. Okay, that is the unit of mobility. It's not super simple, but you have to remember it. Okay, now mention two limitations of Ohm's law. Ohm's law is applicable only if all the physical conditions remain same. So physical condition means the wire is not changing its state. For example, if the wire suppose the temperature increases and the wire melts, then Ohm's law will not be applicable. Okay, so if the all physical conditions, that means temperature, physical state, they are constant, then it is applicable. Ohm's law is not applicable at very low and at very high temperature. If you want to apply Ohm's law at very high temperature, when the conductor is super hot, or when the temperature is very low, when it is super cooled, Ohm's law is not applicable. Okay, there are different branches of physics where they deal with this, but Ohm's law is not applicable in that case. Ohm's law is not applicable to non-ohmic devices. What is the meaning of non-ohmic devices? Like semiconductor, okay, discharge tube, so they are examples of non-ohmic conductors. Okay, diode, transistor, etc. They are examples of non-ohmic conductors. They are part of semiconductor, but semiconductor devices I have mentioned. Semiconductor devices can include diode, transistor, etc. If you only mention semiconductor, then you can mention diodes and transistor as well. Okay, these are the 3 points. You can write any 2 of the points to get full marks. Okay, now give any 2 differences between current and current density. This is this question is taken from your sample question. Okay, it has never came before, but this is a new question and it is included in your sample paper, so I thought might be this question is important for you, so that's why I have included this. Current is defined as the amount of flow of electric charge per unit time. We know that current is amount of charge by unit time, right? Q by T, right? Whereas current density is the unit amount of current per unit area. So current density is I by A. Okay, so current density is I by A, whereas current is Q by T. Okay, unit of current is ampere or capital A. Okay, unit of current density is ampere per meter square. Okay, or ampere meter to the power minus 2. So this is the new question, but very easy to answer. I hope you remember this question and answer this if this question comes in your annual final PU board exam. Now question number 19. Name the 2 factors on which the resistance of a metallic wire depends. So resistance of a metallic wire is basically rho L by A. So resistance of a metallic wire is directly proportional to the length and it is inversely proportional to the area. Okay, if you have to write this and then you have to mention, okay, L equals to length, A equals to area, or you can write it in words. Okay, resistance is directly proportional to the length of the conductor. Resistance is inversely proportional to the area of the conductor or metallic wire. Okay, that's how you can answer. Or if you are answering like this shortcut way, you have to mention what is L, what is A, and the formula. Okay, if you mention these 3 things, you will get full marks, don't worry. Okay, so if you mention the formula, then write these 2 points along with the meaning, then you will get full marks. Otherwise you have to, if you just want to write the answer, then you have to write resistance is directly proportional to the length of the area conductor. In bracket you can write R proportional to L, and then resistance is inversely proportional to the area, R proportional to 1 by A. Don't miss with the square of the area. Okay, some people have written, I have seen, resistance is directly proportional to the square of the area. That is not correct, right? Because people are so infatuated with inverse square law, so they apply inverse square law whenever they can. Okay, so that is a very bad habit. Write the expression for drift velocity in terms of current. Explain the terms used. So first of all, I don't remember the drift velocity equation, so what I remember is NEA VD. Current I is equal to NEA VD. I don't remember how you write drift velocity. So, but they have asked you drift velocity in terms of current. So you have to adapt, right? So you have to, I like to remember this equation. From there I can find whatever relationship they have, they told me to find, right? So VD is equal to I by NEA. Okay, so here I equals to current. Here you have to write drift velocity, I equals to current, N equals to number density of electrons, E is charge of an electron, A is area of cross section of the conductor. So it's not super hard to write everything. Okay, if you write everything you will get full marks. Okay, only people find it difficult to remember this number density of electrons, number density of free electrons. More correct is number density of free electrons. Okay, that will be more easy to more correct. So they will check. In case if you have not written it, they will deduct marks. Okay, so be careful, you have to mention all the points. There are 2-3 more formulas: drift velocity with mobility, okay, conductivity in terms of mobility and drift velocity. You can remember those 2 equations as well. Okay, and remember the terms, so that if they change this question, this is the most asked question, if they change that question to relationship between resistivity and mobility, okay, sorry, not resistivity, conductivity and mobility, or drift velocity and mobility is okay. Okay, drift velocity and mobility is, we know that mobility is drift velocity by electric field. Okay, but conductivity in terms of mobility, that might be asked in your exam, so you can remember that formula as well. Now let's start with the derivation parts. Okay, there are 3 derivations. We will do one by one. 2 cells of different EMFs and different internal resistances are connected in series. Derive the expression for effective EMF and effective internal resistance of the combination. This is the most commonly asked question. Okay, another there is obviously Kirchhoff's law question, but other than that, this is the one of the common question and easy question. So 2 cells of different EMF, epsilon 1, epsilon 2. Okay, EMFs are represented generally by epsilon 1. Some books use small e as well. Whatever symbol you are comfortable, that is fine, but you have to mention. If you are not using standard symbols, then you have to mention what those symbols means. Okay, and different internal resistances. So different internal resistances R1 and R2, okay, are connected in series. Derive the expression for EMF and effective internal resistance of the combination. So what you have to do, you have to find the cells in series. Okay, so suppose this is the equivalent EMF, this is the equivalent resistance. You have to calculate the epsilon equivalent and R equivalent. Okay, this is what you have to find. To find that, what you have to do, you have to connect them to a resistor, external resistor, say R. Okay, now what is the current in the circuit? So current in the circuit, say I. Okay, current in the circuit, say I. So what is the voltage drop across this resistance? Okay, voltage drop across resistance VR is basically R times I. Voltage drop across this resistance is R times I. Now if you connect this an equivalent cell, okay, across the resistor R, then also you should get the same current I. Okay, in this case also the voltage drop should be I times R, right? V is equal to IR. That should be true for normal case as well as the special case, right? Now what is the voltage drop across this R1? Voltage drop across R1 is I R1. What is the voltage drop across this R2? V2. That will be I R2, right? So from Kirchhoff's loop rule, if you apply Kirchhoff's loop rule, okay, you know that if the current I is coming in one of the branches, current will I will be constant throughout the circuit because everything is connected in series. So from there you can say that epsilon 1 plus epsilon 2 equals to V1 plus V2 plus VR. Okay, so if you add the EMFs, you should get all the voltage drops, right? So that is the Kirchhoff's junction rule, sorry, Kirchhoff's loop rule. Now, so VR equals to, you will get epsilon 1 plus epsilon 2 minus V1 plus V2. Now what is V1, V2? V1, V2 we know already, so we just put the values here. IR1 plus IR2. So you can say VR is nothing but epsilon 1 plus epsilon 2 minus I R1 plus R2. Okay, now in this case also VR is IR, and what is the from the battery, what we can say, from the battery epsilon equivalent minus IR equivalent is equal to VR, right? This is the standard equation for a cell, right? So voltage drop is basically given by epsilon minus IR, right? So in this case epsilon equivalent minus R equivalent is equal to VR. Now if you compare, this is say equation 1, this is say equation 2. So if you compare both sides, we can say this must be equals to this, right? This has no boundation with current I, so this must be equals to this. So epsilon equivalent must be equal to epsilon 1 plus epsilon 2, and this must be equals to this, right? So R equivalent should be equals to R1 plus R2. Okay, simple, very simple, easy derivation, 5 marks if this question comes in your PU board exam. Okay, so this is step 1, this is step 2, and this is step 3. Okay, so what you have to do, first you have to write the step 1 equations from circuit 1. We can write this from circuit 2, from equivalent circuit we can write this, and comparing equation 1 and 2 we can write this. Like that you have to write. Okay, and you will get full marks, and if you understand this, is very easy to answer. Next question is derive an expression for effective EMF and effective internal resistances of two cells in different EMFs and internal resistances connected in parallel. So this is slightly difficult, okay, compared to the series one. Okay, in this case as you know that series combination current is constant, but in parallel combination current is not constant. So this will be slightly difficult. We will use the similar technique. This is our circuit 1, epsilon 1, epsilon 2, R1, R2, capital R. Now this can be represented by an equivalent EMF. So epsilon equivalent, R equivalent, and this will be as usual our R. Okay, now suppose current passing through this I1, passing through this is I2, then total current is I. Here total current is I. First of all, if you apply Kirchhoff's junction rule here, you can write I equals to I1 plus I2. What is incoming current? Incoming current is I. What is outgoing current? Outgoing current is I1 and I2. So incoming current equals to total outgoing current. So that is Kirchhoff's junction rule. So we have applied Kirchhoff's junction rule for the first case, right? Now what is the voltage drop across these two junctions? So voltage drop across this will be constant now. Okay, so if you consider the voltage drop, the voltage drop, that is VR, will be constant for both the batteries. Okay, so for both the batteries it will be constant. So how to write that? Suppose we take this, I have taken the direction is little off. Okay, so direction will be, why? Because the batteries are connected like this, no? So current will pass like this. So current will pass like this. This is I, okay, and this will go like this. This is also I. In this case also I have done the same thing. Okay. So current will pass in this direction, it will pass in this direction. Okay. Now, so first consider this path. Okay, so this path is the first path through which current is flowing. So epsilon 1 equals to VR plus V1. Okay, so if you consider this path, okay, let me use this king. So first we are considering this path. Okay, outside path. So in this case you can write that epsilon 1 plus V1 epsilon 1 equals to V1 plus VR, right? Or you can say VR is equals to epsilon 1 minus V1 or epsilon 1 minus I1 R1. Okay, so this is how you can write. Now, similarly, VR equals to epsilon 2 minus I2 R2. Okay, so this is how you have calculated this. Now what to do, how can we simplify these two equations? So to simplify these two equations, because you cannot simply add them and take I1 I2 common or R1 R2 common, because they are all have the same value, right? So what we have to do, first of all, we have to separate this I2 R2 and I1 R1 from these two equations. We have to separate I1. So we can write from this equation I1 R1 equals to epsilon 1 minus VR, okay, or I1 equals to epsilon 1 minus VR divided by R1. Similarly, I2 will be equals to epsilon 2 minus VR by R2, right? So now let's add them. I1 plus I2 equals to epsilon 1 by R1. We are adding them, right? So plus epsilon 2 by R2. I have separated this one by one, okay? Minus, okay, let me use a little space. If you are still having trouble to understand this, let me explain. So what is the value? Value was epsilon 1 minus VR divided by R1. So I can write this as R1, this also R1, right? By division rule I can do that, right? R2, R2. Now what we are doing, we are just simply adding them, okay? So I1 plus I2 equals to epsilon 1 by R1 plus epsilon 2 by R2 minus VR 1 by R1 plus 1 by R2. Okay, so the minus negative VR is common, so it is minus 1 by R1 plus 1 by R2. So this is the current I. This is the current I equals to this. Now we will do the same thing and we will try to find the current in this case as well. So from here what we can see, this is the same formula, right? VR equals to epsilon equivalent minus I R equivalent, right? So from here also we will find the current I. So from then we can compare. So if we last case we have calculated voltage from both equations and then we compared. In this case we will find the current and then we will compare. So how to do that? So we can do that by saying, okay, let's take this negative IR equivalent on this side and this on the other side. So IR equivalent equals to epsilon equivalent minus VR. Okay, or I equals to epsilon equivalent by R equivalent minus VR by R equivalent. Okay, now if you compare, this is equation 1, this is equation 2. What we can see? This equals to, first we will find the equivalent resistance. This equals to this, right? So we can say that 1 by R equivalent equals to 1 by R1 plus 1 by R2. So similar to that of the parallel combination of resistances, right? Now what is epsilon equivalent? Epsilon equivalent by R equivalent equals to epsilon 1 by R1 plus epsilon 2 by R2, or epsilon equivalent equals to epsilon 1 by R1 plus epsilon 2 by R2 whole divided by 1 by R1 plus 1 by R2. Okay, you can, let me find some space. This is too clumsy. Okay, because I am going to give you this as note, so I am not deleting too much, so you don't miss out on important things. Okay, so from here I can write the epsilon equivalent equals to, this will go up, right, R equivalent times whatever is there, this one, right? Or you can write this as this, whatever this is, divided by 1 by R equivalent, right? Why I am doing that? Because we know that 1 by R equivalent in terms of R1 and R2, so that is my target. So 1 by R equivalent is equals to 1 by R1 plus 1 by R2. This value, this formula is easy to remember, and in case some numerical problem comes in your exam, you can solve that as well. So epsilon 1 by R1 plus epsilon 2 by R2 divided by 1 by R1 plus 1 by R2. This is the easiest form to remember for epsilon equivalent. Okay. Now there are some other forms, other formulas given in the book, but this is I prefer, okay, many teachers prefer this formula, this equation to remember, because it is very similar to that of the parallel combination, right? Parallel combination of resistors. In this case, epsilon equivalent is epsilon 1 by R1 plus epsilon 2 by R2 divided by 1 by R1 plus 1 by R2. Okay. But you have to practice this derivation. This derivation is slightly difficult and you have to practice it multiple times to remember. This is the step 1. Okay. This is step 2. This is step 3. This is step 4. And here it's a 4 star. Okay, so continuation of the 4. Okay, so that you don't miss out how to write. Now in your, take your notebook, no matter even if I have done this, you take your notebook, okay, and practice it one by one, step by step. If you do it step by step, break the problem into step by step. First you have to draw the diagram, okay. Once you have done it for one, okay, then you can do it for the second one as well. Okay, so first one we have done it for epsilon 1 minus I1 R1. Similarly, for second one it will be epsilon 2 minus I2 R2. Okay, same VR, because they are connected parallel, so this potential will be same. In this case potential is VR, so we have applied the logic of parallel combination and we have calculated this. Okay, so you have to understand this, why we are writing this equation. Okay, why we are writing this equation. So the most important question, that is, arrive the balanced condition of Wheatstone bridge using Kirchhoff's law. So what is the condition for balanced condition? So balanced condition is the current through the galvanometer is 0. Okay, so this is the condition for balance. So condition for balance is the current through galvanometer is 0. Right, now we have to apply Kirchhoff's junction rule or Kirchhoff's current law, KCL, that we say, okay, at junctions B and at junctions D. Okay, so applying junction rule at point B. Now let me know in the comment below what term you use for this junction rule, because in your CBSE book they mention junction rule, but throughout my most common experience I have learned only KCL. Okay, so this junction rule is something new. Previously they also used to have the term called Kirchhoff's current law and Kirchhoff's voltage law, but last few years they have updated it to junction rule, right? Just let me know in the comment below what your college, your teachers follow in your class. So at junction rule at point B, what we use, we can write that this is the incoming current I2, okay, and IG and I4 are outgoing. So IG plus I4. Now you might say, sir, Ig is 0. Why are you using that? Because we have to use something here, right? They have asked us to use Kirchhoff's laws, right? So you cannot put it 0 straight away. Okay, then there will be nothing to do in this case, right? So because they have asked us to use Kirchhoff's laws, we have to start with these values. Later on we will put that, okay, because circuit is balanced, we will put Ig is equal to 0, right? So that is our trick, small little trick. Now here current is at junction D, I1 is incoming, Ig is incoming, I3 is outgoing. So we can say I1 plus Ig equals to I3, or I1 equals to I3 minus Ig, right? Sorry, I just erased everything, my mistake. So junction rule, at point B we get I2 is incoming and I4 and Ig are outgoing, I4 plus Ig. Similarly here at junction D, incoming is I1 and Ig, and outgoing is I3, right? So here we can write that I1 equals to I3 minus Ig. Okay, so now, so this is the first two equations. Now we will take two loops, okay, and we will apply loop law or KVL. First loop we will take is this is our loop, say A, and next we will take this loop, this is our loop B. Okay, you can follow this direction. Okay, so when you are following the direction of current, it will be positive. If you are following going in the opposite direction of the, it should be a cyclic order, right? So you are going in this direction, right? You are going in this direction. So when you are going in a cyclic direction, always you have to remember that it should be in a order. Similarly here also you are going suppose in this direction, it should be a closed order. Okay, then only you can apply Kirchhoff's current rule. Okay, so from loop A, what we can write? Any battery is connected in loop A? No battery is connected in loop A. So we can write I2 R2, okay, I2 R2 plus, this is the direction of current, plus Gig, G is the resistance of the galvanometer. Okay, Gig. Now here we are going in the opposite direction, right? So here we are going in the opposite direction, so it will be minus I1 R1. Okay, and no battery is connected, so it should be 0. So this is our equation 1. Okay, now let's apply the same rule for loop B. Loop B, here we are going in this direction, so I4 R4, okay, then opposite to the I3, so I minus I3 R3 minus IgG equals to 0, right? Sometimes my G looks like a 4, but it is actually a G. Okay, so IgG equals to, because you are going in opposite direction, so it will be equals to 0. No battery is connected in loop B as well. Now for condition of balance, for condition of balance, Ig equals to 0. So this is our equation 2. Okay, say let me rephrase that, make it equation 2, equation 3, and these two are equation 1. Okay, these two are equation 1. Ig equals to 0. Then from equation 1, okay, from equation 1 what we get? I2 equals to I4, right? So this is the first. Ig is 0 and I1 equals to I3, right? These two we get from equation 1. From equation 2, what we get? Ig part is 0, so we get I2 R2 minus I1 R1 equals to 0, or we get I2 R2 equals to I1 R1, or R1 by R2 equals to I2 by I1. Okay, so this is the thing that we get from equation 2. From equation 3, what we get? From equation 3, again Ig is 0, so this part is 0, so I4 R4 minus I3 R3 equals to 0. Now what is I4? I4 is equals to I2. So I2 R4 equals to, what is I3? I3 equals to I1. So I1 R3. Okay, or equals to. So we have taken this negative on the other side, and we have also put the I3 R4 value. So we are doing two steps at a time, right? Now so we want to find R3 by R4. So R3 by R4. So R3 by R4 is equal to I2 by I1. Right? So this was R3 here, R4 on the other side. So R4 gone to here, I1 come here. Right? So it is I2 by I1. Now if you compare this, say equation 4, this is equation 5. Comparing 4 and 5, we can write R1 by R2 equals to R3 by R4. Right? Comparing 4 and 5. Okay, so if you compare both sides, see both equation has on their right hand side I2 by I1. Here also I2 by I1, here also I2 by I1. So you see R1 by R2 equals to R3 by R4. So R1 by R2 equals to R3 by R4. Okay, so no matter, you can rearrange this equation in multiple ways. No matter what you do, you will always get this equation. This is the condition for balanced, this is the balanced condition for Wheatstone bridge. Okay, simple straight derivations. Okay, and I have completed it with the more better way. I hope you enjoyed it. Now next, let us go into the numerical portions. The number density of free electrons in copper is estimated to be 2 times 10 to the power of 28 meter to the power minus 3. A copper wire of length 3 meter and area of cross section 2 millimeter square is carrying a current of 6.4 ampere. Calculate the drift velocity of the electron. So first of all, number density is given. So number density of free electrons is given. N is given 2 times 10 to the power of 28. Okay, a copper wire of length of the copper wire is given 3 meters. And area of cross section is given 2 millimeter square. Now what is millimeter? 1 millimeter is equal to 1 millimeter is 10 to the power of minus 3. 10 to the power of minus 3. Now you see there is a millimeter square here. So 10 to the power of minus 3 whole square. meter square. Everything should be accounted for. All the units should be converted into SI unit. So here it will be 2 times 10 to the power of minus 6 meter square. Okay, so we have calculated n. N is given, A area we have calculated, and is carrying a current 6.4 ampere. So I equals to 6.4 ampere. So they have asked you to calculate the drift velocity. So what do we know? We know that I is equal to NEAVD. Okay, so drift velocity is I by NEA. Length is not required for this part. Maybe in the second part we will check. Okay, I is 6.4, N is 2 times 10 to the power of 28. Okay, E is 1.6 times 10 to the power of minus 19, and area is 2 times 10 to the power of minus 6. Okay, I hope you are solving this numerical along with me. If I just solve the numerical and you just sit there and watching, it will not help you. You have to solve along with me. Okay, so 2 times 1.6 is 3.2, 3.2 times 2 is 6.4. Okay, so they have given in the values so that it will cancel easily. So 10 to the power 28, 28 minus 19, 28 minus 19 is 9, okay, 9 minus 6 is 3, so 10 to the power of 3. Okay, so this is the value. 6.4, 6.4 cancel, so it will be 10 to the power of minus 3 meter per second. Unit of velocity is meter per second, so drift velocity will also be meter per second. Okay, so you can see that drift velocity value is very small as usual, as expected. Drift velocity is obviously very small. Okay, so drift velocity of electron is calculated. How long does an electron take to drift from one end of the wire to the other end? Now we need this length L. Okay, so now you can consider this problem to be a problem from your first PU, speed and distance and speed. Okay, not even first PU, we have solved similar questions in your lower grades as well in mathematics class. So here the distance is L, speed is Vd. How long it will take an electron? Electron is moving with the drift velocity Vd. The total track is L. How much time it will take to reach from starting from here to here? Suppose the time taken is t. Then we know that S equals to Vd, right? S equals to Vt. So here S is L, V is Vd, and time is t. So t is equal to L by Vd. Okay, L is 3 divided by 10 to the power of minus 3, that is 3 times 10 to the power of 3 seconds. Okay, so the answer is 10 to the power of minus 3 meter per second is the speed of drift speed, and 3 times 10 to the power of 3 second is the time taken. Okay, so this is a very interesting question. Okay, but the formula is known, easy formula. Second part is slightly tricky. So even though it's a hot question, okay, first part is easy. You just remember the formula, you put the values, you will get the answer. Okay, so only two tricks are involved. First of all, you have to calculate the area in terms of meter square, and secondly you have to calculate this part. This part is actually slightly tricky. If you don't understand it, you will not be able to answer it. Next, in the following network, find the current I3. So another interesting question, and if you see, this is not a balanced Wheatstone bridge. Okay, if this is a balanced Wheatstone bridge, you can say, okay, 10 by 20, 10 by 5. So if they are, it is 10, it is 20. If it was 5, it was 10, then it is a balanced Wheatstone bridge. We could have said current through this is 0. But this is not. This is not a balanced Wheatstone bridge. So you have to find the current I3. Okay, so how can you solve that? This question came once before, last year also similar question, just slightly different diagram, different values was there, slightly tricky question. Okay, if you want to skip this question, you can skip it, but for those who are aiming for 90%, they have to watch this video. Okay, now here current I1 is going, I3 is going out, so here the current is I1 minus I3. So current through this is I1 minus I3, current through this is I2 I2, current through this is I2 plus I3. We will apply the same principle that we applied for our solving the condition of Wheatstone bridge. Okay, so first we will consider this loop. Okay, first we will consider this loop. Junction rule you don't need to apply. Junction rule is already applied and the values are already given, so you don't need to apply junction rule. First rule we will apply here, second we will apply here. Okay, so first loop, this is loop number 1, this is loop number 2. Okay, we will apply, and in both cases there is no battery involved. Okay, so we will try to avoid the battery, but the current, total current is given. Total current is given, so that makes our life easier. We don't need the battery branch at all. So this is our loop 1, loop 2. Okay, and total current is I1. So from there we can apply that. So incoming current is 1 ampere. Outgoing current is I1 and I2. So first we can write that I1 plus I2 equals to 1 ampere. Okay, similarly the outgoing current is I1 minus I3 and I2 plus I3. So in this case also, if you add them you will get same value. Okay, so I1 plus I2 is equal to 1 ampere because the incoming current is given here. So that is one thing. If we can somehow find some relationship, we can eliminate one of them. So first we have to apply the loop rule in this case. So what is this? I1 times 10. I1, we are going in this direction. So in the direction of current, I1 times 10, that is 10 I1. In this case 10 I1. Now we have reached here. Now we will go in this direction. This is our loop 1, right? This is our loop 1, right? So this is our loop 1. So we started here. We are still moving in the direction of current. So it is I3 times 5 or 5 I3. So plus 5 I3. Okay. Now we are going in this direction. Now we are going in this direction, right? So in this case I2 is going down, but I2 is going in this direction, but we are moving in the opposite direction. It will be minus 20 I2. This is how you should apply Kirchhoff's loop rule. Current times resistance. Are we going in the direction or you are going in the opposite direction? If you are going in the direction, then definitely it will be positive. If you are going in the opposite direction, then it will be negative. Okay, I hope it is clear. If you have still not clear during your regular classes in your lectures, so if you are just relying on that, then you have to remember that current times voltage is the voltage drop across one resistor, right? And if you are going in the direction of current, you can take opposite arrow as well, but that will make things complicated. So you can take both of the sides, you have to take in the single direction. Okay, here also you have taken anti-clockwise, here also you have taken anti-clockwise or clockwise. Okay, so whatever direction, if you are taking anti-clockwise, take anti-clockwise. If you have take clockwise, you can take clockwise, right? Now, so this should be equals to 0. Why 0? Because no battery is connected. No battery is connected in this portion, in this small loop. No battery is connected, so we can put that as 0. Okay. Now, if you see, all the things has 5 in common. 5 is a common factor. So we will remove 5. So if we take 5, it will be 2I1 plus I3 minus 4I2 equals to 0. Okay, so and then this 5 is common, right hand side is 0, so we can simply remove this 5. Okay, so this 5 will be gone. Now let us apply the same thing in the right hand side. Now you tell me what will be the value for voltage drop across this resistance. So voltage drop across this resistance is resistance is 10, current is I1 minus I3. So it will be 10 I1 minus I3. Okay, and then we will go to the we started here, we reached here. Now we will go to this resistance. Now when we are going through this resistance, as you can see, we are going in the opposite direction. So here it will be minus 5 times, what is the current? Current is I2 plus I3. Okay, then again we are going in the opposite direction of the current in this branch also. So we started here, we moved here, we came here, we came here. Now we are going in this direction, right, to close the loop. So here also we are going in the opposite direction. Voltage, so it will be negative. 5 is resistance, current is I3. So it will be 0. Okay. So any doubt, any problem, mention in the comment below. Now here also you can see that 5 is common. So 5, if we take common, it will be 2I1 minus I3 minus 5, 5 is taken common. So minus I2 plus I3 minus I3 equals to 0. 5 is common, 5 we have taken common. Now we will break the brackets. So 2I1 minus 2I3 minus I2 minus I3 minus I3 equals to 0, or 2I1 minus I2 minus 4I3 equals to 0. Now how to solve this equation? So this is one relation, equation 1, this is equation 2, this is equation 3. Okay, so 3 variables, 3 equations. So we should be able to solve these equations, right? First, let me write the first equation. I1 plus I2 equals to 1 ampere. Or let me rewrite that I2 equals to 1 minus I1. So this is the first, from the first equation we can write this. Now what was our second equation? Second equation was 2I1 plus I3 minus 4I2. So 2I1 plus I3 minus 4I2 equals to 0, right? So 2I1 plus I3 minus 4I2 equals to 0. Now we will put this value here. So 2I1 plus I3 minus 4, 1 minus I1 equals to 0. Okay, so this is now started taking shape, right? So 2I1 plus I3 minus 4 minus 4 minus minus plus 4I1 equals to 0, or 6I1 plus I3 equals to 4. Okay, so 6I1 plus I3 equals to 4. Say this is equation 4. Okay, so what was equation 3? Equation 3 was 2I1 minus I2 plus minus 4I3. 2I1. So this is equation from equation 2, equation 3, 2I1 minus I2 minus 4I3 equals to 0, right? Now put the value of I2 in this equation. So 2I1 minus 1 minus I1 minus 4I3 equals to 0. So 2I1 minus 1 plus I1 minus 4I3, or 2I1 minus 4I3 equals to 1. 2I1 plus I1, 3I1. Okay, minus 4I3 was already there, and minus 1 goes to the other side and becomes plus. Now what we have to do from these two equations, we have to eliminate I1 to find the value of I3, right? So here as you can see, this is 6I1, here it is 3I1. So if we multiply, first we write this equation, 6I1 plus I3 equals to 4. Now if you multiply equation 5 with the factor 2 and subtract from this equation, then we will get the I3 value. So first multiply this with factor 2, 6I1 minus 8I3 equals to 2, right? We multiplied each and every term with 2, right? Now we will subtract. Our main target is to find the value of I3 only, right? So 6I1 cancels, I3 plus 8I3, that will be 9I3 equals to 4 minus 2, that is 2. So I3 equals to 2 by 9 ampere. Okay, so answer given to this problem is incorrect. It will be 2 by 9, not 8 by 9. Okay, it will be 2 by 9. Now next question, 3 resistors 2 ohm, 3 ohm and 6 ohm are combined in parallel. What is the total resistance of the combination? If this combination is connected to a battery of EMF 2V, then and negligible internal resistance, determine the current through each resistor and the total current drawn from the battery. Okay, so 3 resistors combined in parallel. Okay, let's first draw the circuit diagram. 2 ohm, 3 ohm and 6 ohm. Okay, are combined in parallel. What is the total resistance of the combination? So in parallel combination, we know that R equivalent, 1 by R equivalent is equal to 1 by 2 plus 1 by 3 plus 1 by 6. So it will be 6, then it will be 3 plus 2 plus 1. Okay, so it will be 3 plus 2 is 5, 5 plus 1 is 6, 6 by 6, so it will be 1. So R equivalent is equals to 1 ohm. So the equivalent resistance is 1 ohm. Now if this combination is connected to a battery of EMF 2 volt, okay, and negligible internal resistance, determine the current through the each resistor and total current drawn from the battery. So not only the total current part is easy. You have to also find the current drawn by the each resistor. How to do that? Is it difficult? It is not difficult. How to calculate that? So if you know, in parallel combination all the resistors are actually connected to this battery, you can consider that all the resistors individually are connected to the battery. Okay, so suppose this current is I1, this current is I2, this current is I3. Okay, so from there we can say that I1 is equal to V by R. Okay, V by R, that is 1 ampere. Okay, what is I2? I2 is again V by R. V will be 2, R will be 3. Okay, so you can write 0.67 ampere. Okay, now what is I3? I3 is 2 by 6, that is 0.33 ampere. Okay, it will cancel to be 1/3. So total current I equals to I1 plus I2 plus I3, that is 1 plus 0.67 plus 0.33, which is equals to 2 ampere. Okay, or you can find the total current I to be the battery divided by the EMF of the battery divided by R equivalent. So 2 by 1, that is also correct. Okay, whichever way you calculate the I, total I, that is fine, but individual current you have to consider that each resistance is individually connected to the battery and you have to apply Ohm's law for each individual resistances. Okay, that is the beauty. So this, even though this looks like a difficult question, actually it is a very easy question. Okay, next question. For copper, the number density of free electron is 8.5 times 10 to the power 28. So similar question, and resistivity is 1.7 times 10 to the power of minus 8 ohm meter. Calculate the conductivity of copper and relaxation time of the free electrons in copper. Take the mass of electron is 9.1 times 10 to the power minus 31 kg, and E is equal to 1.6 times 10 to the power of minus 19. So number density is given some different value, maybe at some different temperature. The resistivity is given okay. Calculate the conductivity of copper and relaxation time. So what is conductivity? Conductivity is very easy to calculate. Conductivity is nothing but 1 by resistivity. Okay, so conductivity is 1 by resistivity. So first calculate the conductivity. One by 1.7 times 10 to the power of minus 8. Okay, you can calculate whatever the value it is. Okay, you can find the exact value using a calculator. I am not doing that because I think it will be cancelled out. Now what is the relaxation time? Relaxation time is m by n is square sigma. You have to remember this formula. Okay, if you remember this formula, you can put the values and calculate the relaxation time. Relaxation time is the time between two consecutive collision of the electrons, right? So what is m? Mass of electron is given here 9.1 times 10 to the power of minus 31. It's mass of electron. Okay. What is n? N is given here 8.5 times 10 to the power of 28. Okay, E square is 1.6 times 10 to the power of minus 19 whole square times sigma. Sigma is 1.7 times 10 to the power of 8. Now you can calculate this value and calculate exact answer. Okay, 9 points. Let me write down the values one by one. 9.8 divided by 8.5. 1.6 whole square is 256. That is 2.56 divided by 1.7 is here. Okay, and 10 to the power values will be 10 to the power of minus 31. This will also go up minus 28. This will also go up minus 8. This is minus 19 whole square. Minus 19 whole square is plus 38. Okay, so you will get plus 7 minus 21 minus 29. So it will be some the order of minus 29 seconds. Okay, so the answer will be, well, I made a mistake here. Okay, I made a mistake here. This 10 to the power 8 was in the power and this 1.7 was in the denominator. So what I make a mistake is this will be 10 to the power of 8. So 10 to the power of 8 should be plus. So if 10 to the power 8 is plus, then it will be 20, 51 minus 46. So it will be 46, it will be 59 minus 46, that will be 13. Okay, so it will be of the order of 10 to the power of minus 13. Okay, so it will be 10 to the power of minus 13. You can calculate the values, you will get this answer, no doubt. Okay, if you calculate this exact value, you will get 0.25. okay, and if you calculate this will be 0.59. So you have the access to the calculator, so you can answer this. And now remember that in your board exam the values are not always super good. Okay, not always you will get the answer, but if you apply the formulas one by one, okay, and if you try to solve this question, even if your last answer is incorrect, you can get up to 4 marks even if your final answer is incorrect. Okay, as long as you are following the steps. For each step you will get marks. For example, if you write this formula and calculate this, you will get 2 marks. If you write this formula and apply all the values correctly, you will get another 2 marks, and for the final calculation you will get 1 mark. Okay, so that's how you get 5 marks. Now last question. So this is the last question of today's lecture. Another circuit based question. I have taken it from one of the midterm paper. Okay, I found this question is very interesting. In the electrical network shown in the figure, calculate the power consumed by the resistance 4 ohm. Okay, by the resistance 4 ohm. So they asked you to find the power consumed by this resistance. Okay, what is the formula for power consumed? So power consumed is VI. Okay, if you remember, power consumed is VI. So if you can calculate the voltage current across this, or there is one more formula for power consumed. Okay, this is difficult to calculate. I square by R, this is the easier formula. Okay, sorry, I square R. I square R is the easier formula to apply in this case. Okay, the only thing that you have to calculate is find the current. Okay, they have given you that I1 current is coming from here, okay, and I2 current is coming from here, and all the currents are passing through this resistor. Okay, I1 plus I2. Now in this circuit there is no external resistance is connected except this. In this case, as you can see, there is a resistance 2 ohm is also connected. So this is a simple problem. Let's start with this loop. Okay, so first we will follow this loop in this direction, next we will follow this loop in this direction. Okay, any one direction is fine. So first we will apply I1 plus I2, that is the total current through this. So I1 plus I2 times 4. Okay, 4 is the resistance. Okay, here also we are going in the direction of current. So R1 is 2 ohm. So 2 ohm times I1, that should be equals to the potential source, right, 12 volts. That is how we apply Kirchhoff's voltage law, right? First we choose the loop, we take the direction of current and we apply whatever direction it is flowing, and based on that we apply, okay, this is the direction of current, so this should be the formula, right? Now if you take 2 common from both sides, then 2 I1 plus I2 plus I1 equals to 6, or now add them, 3 I1 plus 2 I2 equals to 6. Now we apply the same thing here as well. Okay, here as well. So if you apply the same thing here, what you will get? I1 plus I2. In fact, we don't even need the upper portion, only the lower portion is sufficient. I1 plus I2 times 4, that should be equals to 6 volts, right? So I1 plus I2 equals to 6 by 4. Individually, for any closed loop, this should be valid. That is the beauty of Kirchhoff's voltage law. Individually you take any loop, this is loop 1, this is loop 2, individually it is valid for any of the loops, so it will be 3 by 2. Okay, so this is the total current of the resistance 4, right? This is the total current of the resistor 4 ohm, right? So voltage drop, you don't need to calculate the voltage drop. What you need to calculate the power consumed. Power consumed is I4 square times r, so that is 3 by 2 square times 4, so it is 9 by 4 times 4, that is 9 watt. So this is actually an easy question. I thought I just copied question before this lecture from one of my students question paper. So but I thought it may be a little difficult question. Actually it is an easy question. If they added one more resistances here, then it may be a little bit longer question. In that case you have to solve I1 I2 using elimination method, and then you have to put the value I1 plus I2. So our target is to find I1 plus I2, that is the current through this resistor. If we know the current through this resistor, then our purpose is solved, right? So then our purpose is just I square R. Okay. So I hope you enjoyed this lecture. There were some hiccups. I know I made one mistake in our problem, but otherwise this is very easy problem, and we have also done all the derivations and numericals questions. So this chapter is very, very important for your PU board. Numerical questions as well as derivations, two things will definitely come. So practice hard. I will be back with one more lecture in our Friday, right? Friday will be moving charges and magnetism. Bio ma'am and chemistry ma'am will come before me. So till then will be bye. I will be back as usual on a Friday.